In this video, I'm going to introduce the concept of set builder notation. I'm going to do 2 videos on this, hence this is part 1. All right, so first I'm going to write out everything in words. A is the set of all natural numbers less than 5. All right, now I'm going to write the same thing again, but I'm going to use a little notation. Remember, is often interpreted as equals. So A is, so that's that there. A is the set of all, that and that. So the set of all puts things in like these brackets, meaning in this bucket, the set of all natural numbers less than 5. Okay, so that's another way that you could say the same thing. You could write it out in words. A is the set of all natural numbers less than 5. You could also write it as A equals, inside curly brackets, natural numbers less than 5. And they really say the same thing. The way you would want to say, this other way that I've put it here, you would just write that as, or you would say that as A is the set of all natural numbers less than 5. All right, continuing in this way, we could write this as A is x in the natural numbers such that x is less than 5. And this literally says the same thing as the one that came before. So this says the same thing as this, says the same thing as this. They're all saying the same thing. Now even more abstract, we could write this as x in natural numbers such that, so such that is expressed with the vertical bar, such that x is less than 5. This is set builder notation. Now the Zybook may use, and in other classes you may see such that abbreviated with a colon. So you might see this as x in natural numbers such that x is less than 5. But they all mean the same thing. These all mean the same thing. All right, and another way you could express this is just by saying A equals 0, 1, 2, 3, and 4. This is all, because this is all of the natural numbers less than 5. So then you might be saying, well, why would I even write it like in this funny way here with the set builder notation? Remember, this is set builder notation. Really, set builder notation is just putting a statement inside of these funny brackets. But it's a nice way to conceptualize. To conceptualize what the logic is saying. It's like a bucket. All right, so like I just said earlier, you say, why would I want to write something in set builder notation? Why would I need that if I could just write them all out like I have here? All right, so the thing is, like, Well, let's look at a new example to motivate my answer to this question. Let's look at B is the set of all x in the natural numbers such that x is less than or equal to 100. Now, to write all these out, it would take quite a while, right? You would have 101 things to write out. You would say b equals 0, 1, 2, 3, 4. Oh, my arm is getting tired, right? You could even go do something like this, dot, 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 100. And probably the reader would have an idea what you were doing. But still, there is some ambiguity in this dot, dot, dot. What exactly is in there, right? There's ambiguity here. So set builder notation eliminates the ambiguity. That's why we have it. C, let's say the set C is the set of all x in the natural numbers such that x is greater than or equal to 2 and less than or equal to 10. This one you could write out all the elements. And this is what the Zybook calls roster notation. Here we'd have 2, 3, 4, 5, 6, 7, 8, 9, 10. In this example, the set builder notation, you could use that, or you could use the other. Really, it's about the same amount of writing. If you think about how many strokes I use with my Apple Pencil, that they're about the same amount. But in the previous example with B here, there's ambiguity here, right? What is that dot, dot, dot? What exactly is in that dot? What exactly is the writer of this set B meaning by this dot, dot, dot? And that's where set builder notation comes in. It eliminates the ambiguity.